In the designing of Think Mathematics, we use our research on difficulties that teachers face in teaching mathematics, and we synthesize the results and translate them in the design of the book. How does Think Mathematics help teachers implement good lessons? One way is to give them lessons that is based on an anchor task. Every lesson, the anchor task is explicit and is clearly presented in a textbook. As a teacher, I can go into class and implement the lesson straight away because the anchor task has been given to me. This allows me to start my lesson planning at a higher level. Previously, I need to look at a chapter or the unit and decide what anchor task to use for each of the days I have to teach that chapter. But now, that has been done for me. And I can now spend my time thinking about what solutions or methods my students might come up with. How can I organize the discussing of the different methods so that the basic methods are discussed first and the more advanced methods can be discussed later. I can spend more time thinking about how can I provide scaffolding and support for my struggling learners. And I can spend more time thinking about how I might be able to challenge my more advanced learners. Think Mathematics allow me to begin planning my lesson at a higher level. The choice of numbers in the problem seems to be critical. In Think Mathematics, the numbers have been carefully researched so that we can anticipate the range of students' responses. For example, the choice of numbers in this problem, 7, 3, and 2, to give a total of 12, has been carefully selected so that the more advanced learners can come up with multiplicative situations such as 2 6s, 3 4s, 4 3s, and so on. The choice of number is not random. Why is 7, 3, and 2 selected? Is to allow advanced learners to move from additive thinking to multiplicative thinking. It also facilitates the learning of the beginners. The choice of 7 and 3 in 7, 3, and 2 is purposeful. The 7 and 3 allow even the beginners to think about making 10, which is a target method in this lesson. Also, the use of 10 frames, which is suggested by the textbook, facilitates the beginners accessing the idea of making 10. So, Think Mathematics helps me as a teacher because the numbers are carefully selected so that the beginners can access the ideas and advanced learners continue to be challenged. It also helps me by suggesting to me the most appropriate concrete material to use. In this case, to use 10 frames. And because I use 10 frames, the beginners in my class are more likely to use the strategy of making 10. Another way Think Mathematics helped me as a teacher is in terms of the content. In this lesson, where students are learning about half, when I look at the textbook, I see that obviously one way to share the cake equally between two friends is to cut it like so. However, when I look at the other pages, I begin to realize that, the two halves need not be congruent. In Think Mathematics, the pages are designed not just for the students, but also for teachers to be reminded of critical key concepts. For example, in this case, equal parts are not necessarily congruent parts. In our research, we found that many teachers in primary schools, in elementary school, think that equal parts need to be congruent parts. Based on that findings, we intentionally include in the textbook equal parts that are not congruent parts. Think Mathematics helped me as a teacher in the learning of the content itself. These are some ways Think Mathematics help teachers to deliver lessons. A, in planning lessons from a higher level by giving them the anchor task already. B, in suggesting to them suitable numbers to use so that beginners in the class can access the lesson, and yet that set of numbers can continue to challenge the more able students. And C, by giving teachers the necessary content knowledge